Math can be cool, right? Right? I mean, I do math. I'm cool. I tried. Hello and welcome to Math Monday number 6. I'm so glad you decided to join me here. Today I'm talking about something super awesome, super cool. Well, for math at least. And that's the Fibonacci sequence. A lot of you have probably heard about this before, but have no idea what it is. So I'm so excited to be the one to introduce it to you. So the Fibonacci sequence is a sequence of numbers. It was founded by this guy named Fibonacci. So a lot of people ask, well, did Fibonacci, this guy, just have nothing better to do and just had to come up with a sequence of numbers? No, actually, he noticed it happening in nature, everywhere. If you look at population growth of animals, a lot of the time they grow in terms of the Fibonacci sequence. If you look at flowers, so many of them have a number of petals that's in the Fibonacci sequence. If you look at the number of seeds on things like pine cones, a lot of them will have the number of seeds that are in the Fibonacci sequence. So Fibonacci just noticed this and then realized, oh, there's a pattern to these numbers. So the Fibonacci sequence is where each number is the sum of the two numbers that came before it. So we just start with 1 and 1, and then of course the next number is then 1 plus 1. The number after that is 1 plus 2, which is 3. The number after that is 2 plus 3. And we just keep going this way. I think you guys get the point, where every single number is just the sum of the two numbers before it. So you add those two numbers that are right before it and you have the next number. So because of this, this sequence can go on forever and ever and ever, which we call infinity. But don't worry, I won't go on for that long for you. Here's a few of the bigger numbers in the sequence. We have 10,946, and the next term would be 17,711. And then a little bit further along, we have 196,418, and then 317,811. So if you wanted the next one, just add those two together and you have the next one in the sequence. So what's special about the Fibonacci sequence? As I said, a lot of things in nature already have this number of things, right? Petals on flowers. Usually a flower has 1 petal, 2 petals, 3 petals, 5 petals, 8 petals, 13 petals, things like that. So it's found in nature all the time, but there's also something else that's really, really special about it, and that's if we take a term and divide it by the term before it. So if we just start with 3 divided by 2, we get 1.5. That's not that special. We go 5 divided by 3, we get 1.6 continuing. So we see they're close, but they're still pretty different. The special thing comes in when we keep going. 8 divided by 5 is 1.6. 13 divided by 8, 1.625. So we see it kind of honing in on a specific value. 21 divided by 13 is 1.615. 34 divided by 21, 1.619. You see it's even getting closer and closer. 55 over 34, 1.618. We go to 89 divided by 55, and that's also 1.618. What? So we see it just keeps getting closer and closer to this same number. And the funny thing about this is if you keep going and dividing the term by the number before it, and you go to the really big numbers, it gets even more and more accurate. So for example, 17,711 divided by 10,946 is 1.61803. Let's go up to those really big numbers I gave you. 317,811 divided by 196,418. And that is 1.61803.4. So not only are those the same, those are a really, really, really special number. That is called the golden ratio, also known as phi. Okay, phi is this fancy symbol, because it's a Greek letter. Yay, Greek letters! 1.61803.4. And that's phi, and it keeps going forever. It's actually another one of those irrational numbers that I've talked about before. That's a whole other video. I'm not going to go too much into the golden ratio today, but you've also probably heard about it. There's so many things in our world that are designed to fit around the golden ratio. So much art, so much architecture, all golden ratios. So that's another topic for another day. This is just another situation where nature probably came before math and somebody just came along and noticed the math, okay? His name was Fibonacci this time, and he was a pretty cool guy, at least for math, which I think we've decided you probably can't be that cool in. Anyways, that's a Fibonacci sequence. I think it's pretty awesome. Thanks, Fibonacci, for figuring that out for us. And thanks for universe for just being really cool and weird and having so many patterns. Anyways, bye.